Hey, thanks, Sarah. I'll get started. Yeah, just want to welcome everyone joining us today. I'll be chairing today's seminar. I'm Professor Andrew Warnes. I'm from the School of English in the Faculty of Arts, Humanities and Cultures, I should say, here at the University of Leeds. Um, I, I work in the area of literature, American literature, food, hunger, so-called food revolution in the United States during the post-war years. But the focus today is very different from that. The focus today is the work of my colleague Nik Watson, Professor of Artificial Intelligence in Food in the Faculty of Environment. And Professor Watson's title is Can Artificial Intelligence Save the World and Everything on It? For which he's given us a spoiler alert, perhaps an unsurprising, alas, probably not. So we've got a fascinating talk ahead today. Before we get into it, I just wanted to say a few words by way of introducing Nik. Nik's a chartered engineer, gained his master's in mechanical engineering from Hull in 2006, and he gained his PhD in chemical engineering here in Leeds in 2010. For 4 years after that, Nik worked as a postdoctoral researcher in our food physics lab, and during this time developed a number of acoustic sensing technologies for industry partners. 2014, Nik was appointed Assistant Professor of Chemical Engineering at the University of Nottingham, becoming an Associate Professor there in 2020. At Nottingham, Nik worked on combining in-process sensing, acoustic and optical, with machine learning for a variety of industrial applications, and developing further expertise in the broad area of digital manufacturing within the food and drink sector. Returned to Leeds in 2023 as Professor of Artificial Intelligence in Food, obviously a very timely and important area that interests us all. During his career, Nik's published over 50 journal articles, and their projects funded by Innovate UK, EPSRC, STFC, and the Royal Academy of Engineering. And as I say, we're delighted to welcome him back to Leeds and welcome him to the seminar series of the Global Food and Environment Institute. For anyone who doesn't know, the GFEI is an interdisciplinary research community here at Leeds. It brings together members from across academia, joining the humanities and sciences, industry and policy to work on the integrated challenges of food security and climate change. And there's a lot of information about our work on our website, which I think may be on the first slide. It's leeds.ac.uk/global food. This seminar is part of a series of seminars, so please do check the chat function, the link to other seminars in the series that we advertise on Ticket Source. The last thing for me to mention is just that we'll be following standard seminar etiquette, so please ensure your cameras and microphones are switched off for the duration of the seminar. Nik's presentation will take about 20 minutes, and during that time I'll be keeping an eye on the chat function. So please do use it, addressing it to everyone with any questions that you have. At the end of the presentation, we'll have 10 minutes in which I'll collate questions and put them to Nik. So finally, let me just remind you that the seminar is being recorded, and a recording will be made available via YouTube afterwards. So yeah, so now with no further ado, welcome, I'll hand over to Nik.
Thank you, Andrew, for that kind introduction, and thanks to the Global Food Environment Institute for giving me this opportunity to speak. So I'm going to talk about, can AI save the world and everything in it? And as Andrew said, I'm a Professor of Artificial Intelligence and Food in the School of Food Science and Nutrition. But really, what I've been interested in my career is, I remember as a kid watching Back to the Future and all these other films and seeing these wonderful technologies. And I thought to myself, I cannot wait to be an adult and to have my hoverboard, have all these wonderful things. And then I got old, and guess what? I didn't get it. And that's what's really driven my research, especially in the area of digital technologies and food, is why is all this promising ideas and technologies not delivering the real world benefits? Why haven't we got hoverboards? So I don't do fundamental research in AI or machine learning or sensors. I look at what are the opportunities and the benefits they can apply they can provide to food systems, and what are the barriers that are limiting their adoption currently. And within this talk, I'm going to talk about AI, and then right at the end, I'm going to talk a bit about how we can apply it to food. And in putting this together, I'll be honest, it's about 95% on the AI side of things, but we'll talk about a bit of food in the end. So first of all, I thought we would find out what is AI, and I can't think of a better way of finding a definition of AI than actually asking the AI itself what it thinks it is. So that's what I did, and I went on my AI assistant and I put that in. And I think the first interesting thing is I obviously didn't ask the right question, because I had to say, no, do that again. And then it starts apologizing to me. And I think that raises our first interesting question about the relationship we have with these technologies, how we treat them, and how that might influence how we interact with others in the real world, so to speak. We'll get onto that in a bit. But if we go through all these different definitions, and we'll just pick one. So if we go through the Oxford dictionaries, AI is the theory and development of computer systems able to perform tasks that normally require human intelligence. There's something about solving a task. And I always think with AI, the artificial bit's easy to understand. It's the intelligence bit that's difficult. And more, I think the discussions about AI should be philosophical, spiritual. We should have more of people like Andrew, for example, from the arts and humanities, engaging in these kind of discussions and the impact they're going to have on us. I think that's really, really key. But if we just stick with AI being a computer or a non-human, non-biological technology solving tasks, being intelligent, I think we can take that. So I thought I'd talk about what are the different types of AI. And I think there's two main ones that we'd talk about. There's AGI, which is artificial general intelligence. And this is the picture on the left. This is Terminator coming to get you. And what AGI is, it's about developing methods that can replicate human intelligence. Because what humans are really good at, we're not the best at anything. We're not the fastest creature. We're not the quickest climber. We're not able to bend in weight. We're not the best at these, but we're really good at lots of different things. And that's what separates us. So that's artificial general intelligence. And that's what people are really aiming towards. And when you see all these scare stories, that's generally what they're talking about. The vast majority of AI you will encounter in your life is what we call narrow AI. And this is an AI which can do a single task. So if we look at the middle there, we could build a computer imaging, computer vision system and a machine learning AI model to determine, is a picture a cat or a dog? So there's my cat Simba at the bottom. Now, this is great at doing that, but that's all it can do, determine if something is a cat or a dog. So if you were to show it a picture of an elephant, for an example, it would just try and determine if it was a cat or a dog. That's what it would do. So very narrow, it can do a single task. And the other thing I want to mention is that AI isn't just large language models, ChatGPT. That's a type of AI. Because I think since 2023, where we've all started using it, and it's in every part of our lives, these generative models, these foundation models, I think people think that is what AI is. It's just that, but it's not. It's lots of other things as well, and it's fastly evolving. So the new term is not large language model; it's large multimodal models. So not to be confused with M&Ms, the snack large M&Ms. It's large multimodal models, and these are the types of models that don't just take a text, an image, and audio input. They can handle all the different types. That's really, really interesting. And I think as we try and move towards artificial general intelligence, there needs to be steps. And one of my colleagues, Isaac Schwerer, a very clever guy, published a paper late last year looking at some of those steps you need to go towards that. And he calls it general purpose AI systems. So I'd encourage you to have a look at that. Now, if we break down into the AI, you'll see this other term, ML, machine learning. So vast majority of the AI you encounter is machine learning. And what machine learning is it's where you train a model to predict something. So it could predict a class, so it could predict a cat or a dog, or it could predict a numerical value. That could be a regression task. And what you do is it's matching inputs to outputs. So often you'll see these diagrams here where you'll see machine learning is a subset of AI, and you'll train that model with those images. This figure on the left, you'll often see different ones of this as well. You'll see within the ML box something called deep learning, which is very common now, and it's most of the machine learning. Not all of it. There's other methods you can use, but a lot of it is deep learning, and deep learning is neural networks. So I imagine most people have seen those images where you have lots of circles and lots of lines joining up. That's a neural network. And a deep neural network is one where it just has multiple layers of that, and it has lots to do on the feature engineering at the start. So most of the time, and when I talk about AI, I generally mean machine learning, but there is different types of AI. There's expert systems, symbolic AI, things like that. When we go into the different types of machine learning, again, there's lots and it's growing, but three of the most common ones are unsupervised learning or clustering, and this is where you try and find patterns in data. So this is how you recommend the systems work on Netflix and other platforms. We've got supervised learning, and this is where you label the training data. So if we go back to my cat and dog example, this would be where you have 1,000 pictures of cats, 1,000 pictures of dogs, or even more, and someone has labeled each one of them, say that's a cat, that's a dog. And one of the most other common types is reinforcement learning, and this is where you want a model to get better at a task. So this is used a lot in autonomous vehicles, robotics. You have reward systems, or AI methods that are used to play games. So the classic one is a breakout or Pong, reinforcement learning. Lots of other methods, as I say, though. So active learning, semi-supervised learning, continuous learning, transfer learning, federated, lots of different methods, but these are the kind of main ones. So what's the story so far with AI? And started off with Turing in the 1950s, who've been doing all the work on the code breaking. And then with any technology, what you tend to get is this hype cycle, so time on this axis that goes up. Everyone gets excited by new technology. Then we get to the top and people realize actually it's a lot more difficult to use this technology. Does it provide the benefits it promised relative to the cost? So we can think of things like maybe blockchain, maybe the Internet of Things, and some of them do, some of them don't. But what tends to happen after that hype cycle is everything comes down a bit, and then we start getting this a bit more research and a bit more, okay, yeah, this is good, but in these areas. So we get this kind of tempered expectation. That's when we get the real world benefits. And AI is a classic example of that. So we had information theory, and we had the first AI winter in the 70s, where actually it's probably not as good as it thought it was. Then we got expert systems. And then we had a second AI winter in the 80s to the 90s. Then we get this growth again, and the deep learning. And deep learning really it's been driven by three things happened around that same time, which were really, really important. The first thing was with neural networks as a technology have been around for decades, but there was a problem with how you train them. And in 2005, Jeffrey Hinton and his group in Toronto actually found a new method to how you could actually train these large neural networks effectively. So that was a breakthrough. The second thing that happened was we had a lot more data. So machine learning, it's really important. The most important thing is your data is representative of the system and the problem you're trying to build that model. So we had a lot more data because of things like the Internet of Things. We've all got multiple devices all connected to the internet. And the third thing was the computing power. We started in the noughties into the 10s, getting a lot more computing power, and that's online now. So we're in this area here, and the reason I always like this gap is because I think a lot of these figures will just show this purple line saying it's going up, it's going to be great, we'll have AI everything, but we're not really sure. Will we get a third AI winter, or will we get incremental progress? I'm probably in the incremental camp, but we need to wait and see. I think one of the things to talk about with AI, so AI in data, digital, robotics, it's all part of the fourth industrial revolution. And I think the thing that's really interesting is the rate of change. So I've got a whole lecture on the industrial revolution. It's really, really interesting, but I won't go into all of it. But I think the thing to look at is the length of these bars at the bottom. So if we look at the first industrial revolution, which was mechanical, water and steam, you think of the mills, we've almost got 100 years there. Then we get into about another 100 years, slightly less, for the second industrial revolution. So we've now started using electricity, railroads coming on board. Third, the use of IT systems, much shorter than today. So we are seeing technology is actually driving the change of things a lot quicker. And this is something we've got to be conscious of, especially in a university environment where we often don't respond. Most of the conferences I go to, they were talking about Industry 5 about 5 years ago. Now it's Industry X, Society X. So it is vastly evolving. We've got to think, what does that mean for AI? I mean, I would encourage you, I didn't have time to put it into the presentation, but just look at the development cycle of technologies such as electricity, the internet, and then look at it at AI and see which ones and how they're moving. Obviously, AI is underpinned by things like electricity and the internet, but I think it is moving fast. And it's really interesting to see if it will continue, because there's an interesting paper out a few weeks ago around these large language models. And actually, what they need is lots and lots of training data. And the latest one, it's almost got, you know, such a large amount of data already that there's not enough data to train it and improve it. And it's not like pictures of cats, because there's so many of them. It's the edge cases, the kind of long tail of your data distribution. There's not enough examples in there, and that's where these technologies fall down. And I just like this as an example of that accelerating change. I'm sure most of you have seen this. It's Will Smith eating spaghetti. This was about a year ago. So I think we can agree this isn't that good. This is 1 year. This is 2024. Whoops. Use bad language there. But as you can see, it's advanced a lot in a single year. And I'd encourage you to think about other technologies that you use. Like if you think about the mobile phone, how much has that changed in a year? Those early prototypes, how long did they take? Really, really important. Now I want to go through my kind of thoughts on AI in terms of the good, the bad, and the ugly. So AI, machine learning, what is it good at? For me, it's really good at identifying relationships in large and complex data sets. So as humans, we're constantly trying to make decisions, and we're usually not that good at it. And we get better with age and experience, but constantly making decisions. One of the things we struggle with is understanding large dimensional problems. So, for example, I'm in the process of moving house, and if you're buying a house, you could build a model to predict the price you should pay for a house, and you might want to consider size, number of rooms, number of bathrooms, has it got a garden, parking area, crime rates, schools, commute distance, energy efficiency. There's a whole range of things you could plot. For machine learning, we would call them features or inputs to our models. If we have 20 of them, 20 inputs, humans, we really struggle to understand things past 2 or 3 features or 2 or 3 dimensions. If I draw you a graph of X and Y, and I have maybe number of rooms on the X and Y price of house, and we see it going up, we would understand that. Okay, more rooms, it's going to cost more. 3 dimensions we can understand. When we start getting into those larger ones, those larger dimensions, we really can't. And so this is what, for me, AI and ML is good at, identifying those relationships. So what does it allow us to do? And if people ask me what AI is good at, I said it's about making better decisions faster. That's what it enables us to do. And I call that being more lucky as well. Because if you think about what in scientific discoveries through the years, some of the breakthroughs, so I've got the penicillin image there, these were discovered by accident. They were trying out experiments in other areas. They left the Petri dish and they noticed no bacteria was growing in that area. Lots of other examples in drug discoveries. Drugs were trying to be developed for one area, they're found to be good in another area. Stainless steel is another example. And I think this is where AI is going to have the biggest impact. So a lot of my research is in things like waste reduction, making better decisions, process efficiency, systems efficiency, resilience. But I actually think it's going to be the discovery of materials, as it's doing in material science, as it's doing in pharmaceuticals. I think that's the big area we're going to see these advances. And just a couple of quotes I really like, because I think one of the problems we have with AI is our expectations. And I love this one. All models are wrong, but some are useful. I think that's something to remember. I'm not going to try the French there, but it's the Voltaire quote of the perfect is the enemy of the good. And I think that's what we need to understand the context of these models. What is good enough? I mean, it'd be great if we could build self-driving cars that never crash, but that's going to be really, really difficult. The reality is, if we could cut road accidents by 50%, that would be huge. But our expectations aren't quite there. We'll turn on the newspaper and it'll say self-driving car crashed, someone injured, which is sad, but it doesn't show that actually this is the right way to move. It's really, really important. So what's the bad? I think a lot of these technologies are black boxes, so correlation doesn't equal causation. So this is one of my favorite websites. And this is various correlations. So this is sociology, PhD, doctorates awarded in the USA over years and worldwide non-commercial space launches. And as you can see, there's fairly good correlation, but probably not linked. The other thing is actually understanding what it is. So here's that dog again I was showing you, and here's loads of muffins. Now, I think we'd all see they look quite similar, and a simple classifier might confuse those as dogs. But the AI machine learning system doesn't know what a dog is, doesn't know what a cake is, doesn't understand these things. And that's, if you look at the UK's AI strategy, a lot of it, and a lot of the areas we need to work in to get these technologies in the real world is around explainability, is around interpretability. And these things can be done, but it's a bit more difficult than your standard methods. So we go to the ugly. These are the things that worry me a bit. We've probably seen examples in the news around bias in AI, so things like facial recognition technologies used by the police might be a criminal. There's lots of these AI tools are used for CVs and areas like that, and they've got inherent bias. And I think my final here is the bias isn't in the model, it's on the data that's used to train the model. So you have to get that data right. Second one is the ethics of this. I talked about supervised machine learning, and someone needs to label that. They need to label these pictures of cats and dogs. Most of this labeling doesn't happen in the Western economies. It's in the global South. There's people sat there looking at pictures all day long going cat, dog, pizza, tree. And we've got to wonder if that's ethical and what's underpinning some of these models and these AIs. But my biggest concern and my biggest worry is that AI doesn't provide the benefits from those who need it the most. And it just makes the rich and those who have and those who can be richer, do more, have more. And this is what worries me, because, you know, I read a really interesting paper last year that said there's no point being an AI researcher at a university, because even if you're developing new methods, you've got no way to test them. You haven't got the computational power of Google, Microsoft, Amazon, you haven't got the training data set, so you just can't compete with those. And this is one of my biggest worries, and I spend a lot of time thinking about how we can democratize it and make it benefit all. I haven't got into the job piece, but you know, the quote that sits with me is AI won't take your job, but someone using AI probably will. And I think that's important. And just a final point on this is these were a couple of things that were just in the news yesterday that I saw last night, so I just added them in. There's a new idea that Microsoft AI, so your Microsoft Copilot, will start saving screenshots, and it's meant to give you this great experience, but there's privacy issues. What if you're on banking? What if you're maybe some of the websites you go on, you don't want people to see, or you're on emails, or you're handling something sensitive, so we've got to be careful of that. My gut feeling is they're doing this just so they've got more and more data, because most of the data in the world, if you look at ChatGPT and things like that, originally these were languages and this was text data, but most of the data we interact with isn't. And I think they want this to try and improve the performance of the model. That's just my opinion. And on the right here, this is a bit worrying as well. This is all the papers in PubMed, and this is for keywords and or just words in the text. And the word delve, it's well known, ChatGPT overuses the word delve. We will delve into the important topics. In 2023, the word delve, look how much the count of the results, it went down a bit in 2024 because people started in general ChatGPT saying it shouldn't just be saying delve all the time. So that's really interesting, how it's influencing science. In terms of these AI technologies, I'm a big fan that AI is not there to replace humans, it's there to augment them. And a lot of the times we're making decisions, they're difficult decisions. So I think it's about humans and the AI technologies working together. And here's three classic examples. Airport security, so we have the scanner systems, but also humans looking at that data and working together. Self-driving cars, so these are making critical decisions in real time that impact safety. And lots of sensors, lots of predictive models. But what these cars do, most of them, if you're driving on a nice clear day, on the motorway, clear lines, they're happy with that. You go to a complex urban, rural environment, bad weather, they turn off and say, human, your job. And there's lots of work now about is the future of Uber, self-driving cars, but where then a human sat somewhere in the world, and when it gets to a difficult position, they remote in and drive it. So this driver could actually be driving all over the world. Lots of interesting issues, and one of my favourite examples is sport. I mean, we're all sports lovers will all be aware of how technology's been in and some of the backlash. And it's often not the technology that's wrong; it's how humans are using it in that system. So there was a lot of football clubs last week saying we want to get rid of VAR. I'm a big cricket fan. I think it's great we get better decisions, but has it ruined the game for me? I used to love it when the umpire's finger went up, someone was out. Now we have to wait for all these cameras and reviews. So is better decisions actually a better experience? We need to maybe think about that in the context of where we're using these technologies. The other point I'd like to add on these is all three of these use multiple technologies, multiple sensors, multiple decision support tools, and they're evolving over time. Airport security is very different to what it was 10, 20 years ago in some airports. Right, I've gone over time already, so I'm going to get onto the food bit. So if we start with food, I won't go through this, but food manufacturing, this is a slide we always try and show to the research councils when we want them to give us some funding. So it's the largest manufacturing sector in the UK. I think about 1 in 4 people in the UK work in food systems. So whether it's primary production, manufacturing, distribution, retail, around there. So in food manufacturing, 31 subsectors and 98% of them are SMEs. So lots of small, medium-sized enterprises. In terms of its impact on the environment, 1/4 of all global emissions come from food production. And it's an extremely volatile sector. So it's been impacted currently by energy prices, climate change, feedstock availability, workforce availability, so COVID, Brexit, and we can just see what's going on with the UK price inflation. Thankfully, it's come down this year, but it's still high. And I'll just finally mention a couple of projects we're doing in this area. We've got lots of detail on these, and if anyone's interested, I'm happy to share it with them. A couple of projects. One is our EPSSC project. This is Enhancing Agri-Food Transparent Sustainability. We call this EATS. And this is really about how can we make better sustainability decisions in food systems, but at the systems level. So what tends to happen is the different actors. If you think of a food chain as something's produced in the farm, goes to a factory, something happens to it, goes to a supermarket. It's more complicated than that. But each of those will be trying to make the decision, the sustainability decision that's best for those. And what we want to use is data and share data in a way that people trust to make decisions at the supply chain level. So that's led by University of Aberdeen, other universities involved as well. And our most recent project is a BBSRC funded partnership with CSIRO in Australia, and this is AI optimized fermentation and sustainable protein production for food side streams. So waste valorization is a big area. Can we turn waste into ingredients and food that people can use? But the big problem you have here is the waste is so variable. So the same strawberries in the UK and in Australia have different compositions, and you might need to use different processes. And as you go through that process development, it takes a lot of time, a lot of cost. So can we use the AI to optimize that? And then once we've learned it for strawberries, can we transfer some of that knowledge to another side stream? Spinach, peaches, something like that. And that's some work we're doing in that area. So I've gone on far too long. So this is my summary. So AI is a rapidly evolving technology, but like with any technology evolution, it's not linear as well. It tends to go in jumps and steps, slows for a bit, and then jumps up again. There's a big gap between expectations versus reality. The key is having the right data. And I'll often get asked, oh, how much data do we need? It's not about how much. It's having data that represents all the variability in the system you're trying to model. It captures that, because in the lab, we can often capture a nice little training data set. But then when we try and apply it in the real world, where it's a lot bigger and varied, it's challenging. My main concern is, will AI benefit everyone, or those who need it the most? And the more complex the problem, and trust me, in food, we have lots of complex problems, it's more challenging the solutions. So yeah, many thanks to all my collaborators and funders, and GFEI again for letting me talk. So I think that's back to you, Andrew.
Great, many thanks, Nick. I think we might have time for a couple of questions. I'm keeping an eye on the chat. Nick, do you think
on the screen and we can see you?
Do you think compared to the food culture we have now in the
Yep.
UK, it's obviously a big topic. Fast forward 10 years, what changes do you think AI might we expect to see?
In food culture.
Well, yeah, I guess I'm thinking about the shopping experience
Yeah.
and the food availability, but that's just my own sort of bias. Food generally.
The short answer is I don't know, and I don't think anyone does. I think what we will probably see. So I think if you look at like the AI assistants now in ChatGPT, they're kind of very much based on language, and we're talking about multimodal, so taking video, sound, and other things. But the output is usually something on our computer. Now, what if that output, what if it was attached to a 3D printer? What if it was attached to a robot? What if it was attached to a car? So if you think of a 3D printer, there's lots of work in 3D printing food. So you can imagine as these models grow, it could be that, you could prompt it, and then, you've got your robot kitchen, your robot fridge, your robot cooker, your 3D printer, and that does the cooking for you and prepares that based on the ingredients you've got. So I think there could be something in that. It could be around apps on your phone when you're going around the shops making better choices. So it could be you have your AI assistant in your augmented glasses that will say, you'll walk past and you'll pick up something, and it will say, you know what, Andrew, based on your medical records and the goals you set on my fitness pal and the data I'm getting from the scales you stood on this morning, I'm picking on it will make recommendations and stuff. But I think it brings in some really interesting discussions there about privacy discussions, but you could see that being exploited, couldn't you? You could see a tag coming up saying, instead of buying product A, buy product B.
Yeah, I'm imagining the kind of driverless car preventing me from going into McDonald's. And Jane Wen, I think serendipitously, Jane Wen has asked a related question, which I think you've already kind of answered, about what new opportunities do you think the large language model can bring to agriculture, food-related research? We have a couple of other questions, but if you could, yeah.
With large language models, I think it will. I think one of the areas in research. If we look at how you do research, you normally start with a literature review, and you go through that, and the PhD students, or when we write proposals, it takes a long time. Or in our group, we try and build data sets. So one of my researchers, Alex, he spends a lot of time going through papers and extracting data. And we just started exploring the use of large language models to actually go through and do that effectively. So instead of him spending 3 hours a day for 6 months reading papers and extracting their data sets, so we can use that and add in all the metadata you need to that to then build a model. If we could do that, if we could build a tool that does that, the concern we've got with it, though, is what happens if some of those papers aren't great, they're not repeatable, and they then go into a model that we're using to make a prediction on something like food safety. So I think that worries us. But then you could argue, even if we did it manually, the human could make a mistake, or it could just be an error in the paper or in the way we're doing it. So I think it's back to what I was saying about the better decisions faster. I think it'll allow us to do areas in that. I think it'll do a lot in identifying things like what crops we should grow, how crops can be used differently. I think a lot in the food manufacturing space, and a lot of our most recent projects are around how can we reformulate food so it has a lower environmental impact but the same great taste, performance, nutritional performance, cost. Because there's so many foods out there and so many biological materials, it's such a big problem, such a big search space, and typically you would just read the literature, try a few materials out, see if they work in your product. So I think it will be used a lot. AI in general, maybe not. A bit of that will be the large language models, but anyway. So I'll let you ask some.
Yeah, we've got a few coming in now, and I think let's try and get through a couple. Lewis's question kind of flows nicely from that. Lewis Wallace asks, what aspects of AI do you think legislation will look to regulate? What are the potential limits to progress?
Yeah, there's more and more work going on around this. Knowing Lewis, he's probably interested in food and the food kind of safety aspects. And my thought in this is what we need is case studies around. So I think the context is important. If you're using a AI system predict the quality of food, so you reduce waste, give a better consumer experience, then you're probably going to be less stringent if you're using this for something, say, to detect allergens or unwanted microorganisms, so food safety risks. So I think the regulations will be around how humans and the technologies work together. I think it'll have to be done like that. I can't imagine we'll ever get to a position where we're getting fully autonomous decisions on things that link to safety. I mean, I think that what will follow is what's going on with medical imaging, where traditionally you would have, say you had a scan for, say, a tumour, you would have two experts look at it, and then you'd have, if they both agreed, benign, malignant, fine. If they don't, then it goes to someone with even more experience. I think what we would have is the kind of AI systems looking, and then you'd still have that human in the loop. So that's where how we do it. But there's lots going on about how we regulate this, and I'd encourage Lewis and others to look at the responsible AI hub we have in the UK, because they're doing a lot of work in this area.
Great, thanks, Nick. We've got quite a particular question from Ala that it might be about kind of particular opportunities that maybe you kind of come back to at a later point. Jenny has asked a more general question that might flow from that, and Jenny Sexton asks, I'll just read it because this is my kind of field, and it'd be better just to do it word for word. Reinforcement learning might be useful for optimizing commercial food production processes. Do you know if there's any evidence of this is economically viable? Accuracy versus monetary environmental cost compared with more heuristic business rules?
Yeah, really good question. So I'm not too sure on the reinforcement, but a lot of people, you're looking at Bayesian optimization methods. So when they're trying to reformulate, and some of our work that we're doing a bit with some of our industry partners is looking at, when you try and optimize a formulation and process, what are you actually optimizing it for? Is it to reduce cost? Is it to reduce the carbon footprint? And even trying to reduce the carbon footprint is challenging, because you've got, you know, the carbon side of it, the water side of it, the other part of it. So I think the way we're looking at this is kind of multi-objective optimization, multi-output modeling, and understanding that space. But I think the bit we're struggling with is quite a difficult area, and our approach is to start with some quite simple case studies, see what we can do with there, and then build on it. So in terms of, we looked at optimizing a cleaning process, for example, to reduce the carbon footprint and cost. And even a simple thing like just cleaning a plate or a piece of material was quite complicated.
Great, thanks, Nick. I think it sounds like there's some kind of really interesting potential connections from Arla's contribution. So as I say, we'll perhaps pick that up after the seminar, but maybe the final question, if we've got time. Hira has asked, and again, I'll read it out because it's not kind of quite my wheelhouse, fascinating as I find it all. And Hira has just asked, what do you think AI or deep learning, do they provide accurate information on food freshness and food texture? What do you think are the main issues we've been facing in articulating such problems? Can large and complex deep learning modules decrease the accuracy of such modules, networks used for food quality evaluation modules? There's a question about AI models.
I've seen it in the chat. What do you think are the main issues we've been facing, I think, such kinds of problems? So I think articulating the problem, it touches on a really interesting point that I didn't cover in the talk, which is what is the expertise you need to use AI in a domain such as food. And we do a lot of work with sensors in factories to predict things such as texture, and we could build models that predict the shelf life. And I always say someone needs to understand your food, so you need a food scientist. You need understanding of your processes that you're using in the production environment. You need understanding of the technologies that collect data. So these could be sensors. So we've done some work on acoustics for texture, for example. And then you need someone who understands the data and the challenges in data sciences and AI and deep learning. You will rarely find all four of that that expertise in those 4 areas in an individual person, I certainly don't have it, and I've not met anyone who does. I mean, even food itself, you rarely get an expert who understands all food. So the key there is you need to have really effective ways of communicating and working together as a team, because this type of research is really interdisciplinary. So you've got to overcome some of those barriers of doing interdisciplinary research, which is people understanding what the terms mean, because different terms mean different things to different people, different expectations. Often in digital technologies, especially in sensors, it's really hard to get them to work in factories, but people think you're just going to rock up, put it on their pipe work, put it on their conveyor belt, and it's not as simple as that. You need to get good contact image process, you need good lighting. So I think it's about getting people to understand the problem. And one of the most important things is understand the problem you're trying to address. So, and understand the value proposition. So what's the cost of the solution relative to the size of the problem? I think a lot of people get kind of excited by AI in digital, and they just want to do it without thinking about, are they actually doing it for the right reasons? And we kind of say we focus on digital solutions, but the reality is we just focus on solutions, because that's what we need to look at. If digital is something that does it, and data and AI, great, but don't get too excited and blown away by that. And that's one thing that worries me. So that's about, and I'll articulate the second part is deep learning model can decrease the accuracy of such networks used for food quality and development. Yeah, I think, not sure I fully understood the question, but I think one of the challenges as well is you collect some data, train a model, have it in the real world, it's working. Now, food systems are constantly changing. If you get your best product, it won't have the same, it'll have the same main ingredients in it, but that milk might have come from somewhere different, the flour might have come from somewhere different, the cocoa beans might have come from somewhere different. They'll have inherent variability within them. So if you build a model on a month's worth of data and suddenly they start changing these, your model might not be representative, or the data coming through and what you're trying to apply it on might not be representative of what it's trained on. So that's why we've been looking at areas such as continuous learning, self-learning systems. These are really important, because these are the barriers, and these are what limit taking a really good research idea, a really good 4-star research paper into something that can go in the real world and provide benefits all day, every day. Yeah.
Great. Thanks, Lee. Yeah, I mean, on freshness, something I learned yesterday was that Marks and Spencer's, when they first introduced cakes into the food hall, the best before time was a time, it was an hour of the day, like best before 4 p.m. So that's what it was like, I guess, in the 50s, it would have been, but that would have been enormously wasteful. So
yeah, and it's the culture that we were talking about before all the participants joined the call. I mean, my parents will still, when they go to the supermarket, go through every bread and look at that. They've got it in their mind that you can't eat the bread once it's gone past that. And I'm like, look, just look at it. So I mean, yeah. I'd just like to say for everyone listening, please follow all health and safety guidelines. But you can just look at it and tell. And I mean, understanding what's the difference between best used by and best before, and all these things are different. But there is quite a lot on work going on in predicted shelf lives to try and have food go on for longer. But then there's an interesting point of, does that just create more food waste, or does it? It's a really, really complex problem. Yeah.
That's great. We must end there. We've gone badly over time, but absolutely fascinating. There's some prospects for very fruitful connections, and we'll follow that up with Arla and others. And thanks to everyone for your comments today. And thank you, Nick, for a fascinating talk and really fascinating answers to those questions as well. Okay, so thanks everyone, and we say this recording will be uploaded to YouTube in due course. Cheers.
Bye, thanks a lot, everyone. Take care.